All right, 7th graders, section 9.3. We are now going to solve quadratic equations using square roots. I actually think you're going to enjoy this because this is more algebra based and less about graphing and stuff like that. This is actually pretty easy. So I think you're going to like it. So what are you going to learn today? You're going to learn how to solve quadratic equations with squared roots and how to approximate the solutions of quadratic equations. So, solving quadratic equations using square roots. Earlier in this chapter, you studied properties of square roots. Now you can use square roots to solve quadratic equations in that form. You're going to first isolate x squared on one side of the equation to obtain something like x squared equals d. All that means is that you are going to get rid of everything but the squared term. Notice this though. What term is missing? This is standard form. Square root property only works when that term is missing. When you do not have that bx term, you can use square root property. All right, this is something I want you to put a star around. If you're taking the square root of d, or x squared equals d, which means you're going to take the square root, the square root of a positive number when d is bigger than 0, you're going to get two real solutions, positive and negative root d. When d is exactly 0, the square root of 0 is 0. Therefore, you only have one real solution, which is 0. And if d is less than 0, that means d, you're taking the square root of a negative number. The square root of a negative number does actually have answers, but they're not real solutions. So you're going to say no real solution. Number 1, 3x squared minus 27 equals 0. Just remember, get the x squared by itself. That's it. That's all you have to do. So 3x minus 27 equals 0. I add 27 to both sides. So it'll be 3x squared equals 27. I now divide each side by 3 because of the division property of equality. That gives me x squared equals 9. And do not tell me the answer is 3 because it's not. You're now going to take the square root of both sides, which gives you x equals positive and negative 3. Now some of you may say, Mr. Humphreys, why can't I just factor out a 3? And then after I factor out a 3, I factor into binomials. We've already done this. So then, I'm going to get x equals positive 3 and negative 3. You're right, you can do that. The problem is that factoring doesn't work for everything. And so now what we are doing is starting to find out other ways to solve quadratic equations that cannot be factored. Hence the next example, B. So write down x squared minus 10 equals negative 10. Well, if you try to factor this, you just get like x minus 0, x plus 0, which we haven't done that. But we're going to isolate the x squared. So I'm going to add 10 to both sides, and I'm going to get x squared equals 0. I take the square root of both sides. That just gives me root 0, which is just 0. So my answer is x equals 0. Notice what we're using our key ideas. If this number here, which is 9, is bigger than 0, I get two real answers. If my number is exactly 0, I get one answer. And the last one, what then happens if I get a value equal to less than 0, a negative number? Well, here's what's going to happen. I solve this equation. I subtract 11. Negative 5x squared equals 5. I now divide both sides by negative 5. I get x squared equals negative 1. Now I take the square root of both sides, but nothing times itself gives me negative 1. Now, if you already know how to do real imaginary numbers, good. But we're going to put x equals. And we can't do that. So since it's negative, we're going to put, it has solutions. I want to make this very clear. This does have an answer. But the answer isn't real. So we're going to write no real solutions. Do not write no solution. That doesn't work. No real solutions. Example 2. X minus 1 squared equals 25. If you want, you can take x minus 1 times x minus 1 and factor it and blah, 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 blah. Way too much work. I want to get the x minus 1 squared by itself, which it already is. All I do is take the square root of both sides. That gives me x minus 1 equals positive and negative 5. Now this is where it gets fun. Haha, really fun. I then have to add the 1 to the other side, which gives me x equals 1 plus or minus 5, which means I get two answers. X equals 1 plus 5 and x equals 1 minus 5. Now you don't need to write that, but I'm trying to show you what this means. So x equals, well, 5 plus 1 is 6, and 1 minus 5 is negative 4. So my answers are 6 and negative 4. Let's do another example. Let's make this one difficult. Let's do in parentheses 2x plus 1 squared. Let's do 2 on the outside. And let's do minus 4 equals 30. Step 1. Get the squared by itself, which means I want to get all of this by itself, which means I add 4. So I'm going to add 4 to both sides. That gives me 34. Then I'm going to divide both sides by 2. X plus 1 squared, or 2x plus 1 squared, equals 17. I now take the square root of both sides. That gives me 2x plus 1 equals positive or negative 17. Now, if you could simplify that radical, you would, but there's no perfect square. That's in simplest radical form. So you're going to leave the root 17 there, unless it tells you to approximate. Now I'm going to subtract 1 on both sides. That gives me 2x equals negative 1 plus or minus root 17. I then divide everything by 2, and my answer would be negative 1 plus or minus root 17 divided by 2. And there's my answer. Which leads into our next example, approximating them and then rounding them. If I asked you to solve this equation, 4x squared minus 13 equals 15, you add 13 to both sides. 4x squared equals 28. Divide by 4. X squared equals 7. I then take the square root of both sides. X equals plus or minus root 7. If it said just solve it, you'd leave this as your answer. Now, if you got like plus or minus root 20, you'd have to simplify that into 2 root, that'd be 2 root 5, if you got this as an answer. But since it says round your answer to the nearest tenth, I want to figure out, well, plus or minus what? Well, I'm going to get x is approximately negative and positive 2.65 if you round it to the nearest hundredth. Example 4. A touch tank has a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cubic feet. Find the length and width. Pretty easy. A touch tank has a height of 3. Its length is 3 times its width. So we do not know the length and we do not know the width. But the width we could let be W. And the length is 3 times that, so that'd be 3W. So volume equals length times width times height. That gives me 270 equals length times width times height. Really easy equation to solve. 270 equals, let's see, 3w multiplied by w multiplied by 9 is 9w squared. I divide everything by 9. That gives me w squared equals 30. So, I take the square root. That gives me plus and minus root 30. But I can't have a negative value, so we'd only talk about root 30 as our answer. Which, if I wanted to approximate it, it's about 5.5 feet. Now, 5.5 feet is the width. I want to know the length. Well, that's 3 times that. And so that would be about 16.4 feet. Now, I don't multiply 5.5 times 3. I multiply root 30 by 3. So this gives you 3 root 30. That gives you a more of an exact answer. 3 root 30 would simplify into 16.4 approximately feet. Example number 5. The area A of an equilateral triangle with side S is given by this formula. Voila. Solve the formula for S. So solving the formula for S would mean getting the S by itself. Well, step 1, multiply everything by 4. That gives me 4a equals root 3 s squared. Next step, divide both sides by root 3. Next step, take the square root of both sides. Now, since we're talking about positive values, I'd only have the positive value of the square root. So now we have to plug everything in. 4 times 390 divided by root 3. We just plug that in the calculator. That gives me approximately 1560 divided by root 3, which is approximately 30. So the traffic sign has side lengths of approximately 30 inches.